Okay, so this is what you see. Can we see my? Can we see my screen?
But we can't see your screen again. No.
Can we see my screen now?
But
Yes. Now.
Okay, fine. So for those of us that are actually new, please, if you're enrolled into 2 class, some of you on the WhatsApp platform said you enrolled in University of America Cisco class, and then you're here in the University of Port Harcourt. Please, all you just need to do, we're going to enroll you in one of them. I can enroll you from mine, and then you can run that stream. Or if you're going to be here, then you ought to be enrolled from there, or you just concentrate on one account so that you can follow the pace at which the instructor is going. This is the class. Invariably, you're meant to take module 1 and module 2. You can see here, this is the module 1 and module 2 content. And then this is threat actors and defenders. So if you take this assessment here, this assessment is meant to validate your knowledge on module 1 and 2. So meaning that you have to read module 1 and 2 before you take this assessment. And then same thing goes for 3 and 4. And 3 and 4 has to do with the operating system overview group. If you recall, here we talked about the Linux and we're talking about the Windows operating system. So that actually makes up this particular module. And then for this module, which is network fundamentals, you see here it is 5 to 10, meaning that once you get to module 10, you're meant to take this, which I'm trying to see how we can get that done today, possibly. And then you expect to take this exam. So you can see from 11 to 12, once you finish reading 11 to 12, you now take this assessment. All this has to do with network infrastructure, security, which are still fundamentals. Then from module 13, you can see it has to do with threat, attacks, and then trend defend group, which is for 18 to 20. So by the time we get to this, we begin to get into the real nitty-gritty of CyberOps. But from this stage that we are currently is at the introductory level into networking and getting familiar with the environment where you'll be simulating most of these tests. If you agree with me, all this is just to familiarize you with the content and then introducing you into the world of cybersecurity and all. So the real practicals will begin to take place from here, 1820 thereabouts. But they're all very relevant and very, very exciting, very, very important. And recall, most of you us here are, some of you are actually instructors in academy, some of you are lecturing in the university, some of you are from the research institute, some of you are also coming in to make a career as an instructor. So it will be very, very nice to start this from the very basis, from the fundamentals, which is quite important. So this is how we walk through all the assessments. And then we get to 26 to 28, and then you take the skill, and then you take the final exam. And then you're good to go. So this is what is expected of us to do. I will stop sharing this, and then I'll also share the labs we're meant to do. Now, I'm showing all this so that those of us who actually are confused in a way, not knowing what to do, will begin to do the needful. Number of us I don't know what to do, so just a few minutes, I will just share my slide again, screen again. In this case, like I said, I want to share with us the labs we're still meant to do. So let me see. Can you see my screen? Hello.
So we can see your screen.
Okay, fine. So let's go from the very basics. I have also shared this with us on the WhatsApp group. So And I'll keep resending and resending for those who are not seeing it, who probably are joining in you. You just have to see it. On one side, you're taking the online assessment, which is fine. Like I said, that would take about 40% of your assessment. On this side of the labs, it's going to take 60%, as the case may be. So if you pass the online assessment and you fail this, automatically you're not qualified to be an instructor. And if you pass this and you fail that, averagely, there might be some level of consideration because the labs actually entails a lot. But you're expected to pass both of them at a very high score, minimum of 75%, both sides, which I'm looking at 80% for instructors, meaning that you need to do a lot of study, a lot of research, and then, like I said, if you have questions, I have a number of folks who have issues, they try to contact me privately, and then we're trying to see how we can work things out. Hello, can you hear me, please?
Yes,
okay,
yes,
so if you look at what I have here, I look at the first one, which says 1.0.6. So all you need to do is to pick each one of them. I don't know if you can see my screen still. If you can, you see Top Hackers shows up how it is done. Now, if you scroll down, this is all about you watching the video on Top Hackers shows how it is done, and then locate the video on the internet and watch. So you're just meant to watch this. As students that we are, we're expected to find out what is vulnerability being exploited. These are more or less questions with regards to watching the video. Meaning, as an instructor, you need to watch this video to react to those questions. If you don't watch this video, how will you answer it? And because at the end of the day, if you're a lecturer, if you're an instructor in your institution, you're actually meant to print this and then make it available to your student. So it's either way, it's either you type in the solution here and then send, or you write directly to it and then send. So whichever way you need to do. For some folks, it's best for them to just answer it directly on their screen. And then once you write it like this, you can save it as a file, put it in a folder, and then you send it to me. And you can see this. How do you think this particular hack could be mitigated? So you just want to get your own opinion, just like you would like to get the opinion of your students once you're teaching them the CyberOps class of this nature. Now, that's what the first one is all about, which we really want to hear from you and know what your responses are. Now, if you look at the second, question here, the second task you're meant to carry out, which is the 1.1.5. So I expect here, what you do for me here is that you read through the background scenario and require resources. Okay. Hello, can we see my screen, please?
Yes, Doc.
Yes.
Okay, so for the first one, the 1.0.6, which you can see my screen.
It's back.
You said?
The screen is back now.
Okay, thank you very much. So I was just trying to open each of those files and explain, talk to the whatever we have before us, which is the lab we're meant to do. So that when you're doing this lab, you're properly guided. You don't need to do it in a haste, but it's something that you can actually do it when you just dedicate the time. Like somebody rightly said, it's the time. Most of you don't really have the time, but you just have to create the time. And you have to do it yourself. I can see somebody raising his hand. Do you have a question to that? Okay. So there's no question, we'll go ahead. So
I have a question.
Yeah, go ahead, please.
Excuse me, I would like just to know what is counting for those who haven't yet sent labs?
You said?
What's going on about those who have not already sent labs?
We're not in the same lab.
I'm going to send you that night because I was supervising your job. Am I going to be fed?
Sorry, I didn't get you clearly. I don't know if you can speak out. Like it's echoing. I can't hear you very well.
Yes.
What did you say?
What's going on with us? We have not already sent labs because here I'm seeing. It seems to me that you are going to correct.
Doctor,
Okay.
if I heard my colleague, what is going to happen to those who have not yet tendered in their labs?
Okay, what's going to happen to those who have not done their labs?
Yes, and submitted to you.
And that's the reason why I'm doing this review. I'm doing this review to encourage every one of us here to do these labs. And I'm trying to know exactly what the problem is. Is it that some folks don't know what exactly they are meant to do, or they are time constrained and they can't do this lab, or they want an extension? I mean, that's the reason why I'm asking this, because I have a spreadsheet currently and I'm populating this spreadsheet with submissions gotten from students, instructors in this class. And just a few of the instructors have actually responded to the first 4 to 5 labs. I mean, chapter labs or module labs, as the case may be. But then just very few of the instructors. So I'm going through this all over again to just show you that, well, it's not difficult. It's not something that is too challenging at this moment that you can't really try your hands on and get done. And so if you have questions, you can be asking me directly and say, oh, I don't know how to do this, I don't know how to do that, so that we can be on the same page going forward, because I feel by the time you're able to do 1, 2, 3, 4 labs yourself and understanding the pattern and what is expected of you to cover within each week, then you're on the right path in finishing your program. And if you don't understand what to do, then there's a big problem. And that's the reason why I'm trying to go back again this way, because ordinarily I should be teaching right now, but it will be fine to see if this will help 1 or 2 persons to be on the same page with all of us. So for those who have not done it, you still have the opportunity to do the needful between now and Friday. Like I said, the labs are not too demanding, just your time, and then you're done with it. So you still have now to Friday to catch up with wherever we are currently. But in the coming week, we just have to go steadily ahead, because we just have to work within the time frame. So I want to believe you understand me clearly. So for that question, if I get him correctly, we still have between now and Friday to still walk through those labs and submit to me. Is that clear?
Thanks.
Doc.
I think that is well noted.
Oh, thank you very much. Yeah.
Doc.
Yeah, I think that is
Yes,
well
I'm with you.
noted, because I also wanted to ask the same question, since for me, I've been out of my country on an assignment. Now that I'm back, I was actually wanted to request for, for a week to do the lab, because I think I'm almost halfway finishing, and then I said, but we really appreciate for that time that you have given us. Thank you.
Okay, thank you very much for that.
So Doc, I would like to know whether
Yes.
we have to submit it 1 by 1, or we should do it in bulk and send it to you.
You said?
I would like to know whether we are to send the labs. You are to send it maybe when you're done with 1.16, you send it, or we should gather all of them together and send it to you.
Yeah, I said for the week. Remember, we started off last week, and then we got into 5 currently, and it's expected that we did 6 last week, Thursday, and it's expected that you do all the labs as we go. So for that week, everybody is meant to have covered from 1 to 5 to 6 thereabout. And if you haven't done that, I'm saying that I'm giving an extension into this week by Friday. And how do you do that? You just, for each of the file, like currently what you can see before you is you prepare a personal computer for virtualization, which I assume most of us have done that already. We've installed the virtual box. Those who are using VMware, you'll have done that. So once you have done the needful, and please, most of these things you just have to screenshot as evidence to show that you have done it yourself. Some of them, the only way you can translate that is just screenshot whatever you're doing. you know. And once you do that, you put it in the same Word document, good enough for us. And then you save. You save it, and then, like he said, if you're going to be sending one after the other, or you put all of them together. Yes, you put all of them together because now you have a lot of labs that you haven't submitted. You can't be submitting them one after the other. I see some folks just sending 1.0.6 or 1.1.5. That's not so good because we've gone past that level. What I expect you to do is put all of them together for the week we have covered, and then save it in the folder, zip the folder. But in each of, when I open the folder, I'm expecting to see all the files, label accordingly the way we have it in the student labs folder. So you just put it that way. Put your name, save it to your name, and then each file should be there. So once I open each file, I can walk through what you have done, then grade you from there. So what I'm expecting is put all of that together in a single folder, name the folder, zip that same folder, and then send it to my email. If you don't have my email, I could still send my email again to the group chat. I'm saying this because it's a criteria, it's part of the requirement for us to actually finish this course. So if you're not doing it, then you're being left behind. So it's good I have to say this over and over, so that as many of us that can work with this will be fine. I know we're all busy, but you can make out time if you really care. Okay.
Thank you.
You're welcome.
Doctor,
Yes.
I have a question concerning this. Should I really edit this document and add my answers? That
would be perfect. You can edit this document and add your answers. It's okay. It's accepted.
Okay, thank you.
Remember, it's a student lab, so the answers are not there. So you can actually edit it and
One final thing that I saw when I was doing the lab for the virtual machine, I saw it is giving me some difficulty to actually screenshot when I'm using the sniffing tool. I don't know whether any other person experienced the same challenge. How are we supposed to screenshot?
Well, if you're having issues screenshotting, you can just copy that into a new Word document. Do what you. But I think screenshotting won't be a problem. You should be able to screenshot. Check your system very well. You should be able to screenshot. I don't think there's restriction in screenshotting, so but you can check it out and see. You can use other methods, other ways of. You can even just snap it to your phone and have it loaded. It all depends on what you just find a way around it. What you just want to see is that you did the stacks and then you're good to go.
Okay, thank you.
You're welcome. Okay, so I think if this all I'm trying to put across to us. So I want to believe everybody has the lab manuals, and then we can go ahead and then just walk through that and see that we answer all the labs. Like I said, if you have any issue with the labs, feel free. You can just post me anytime and tell me, oh, you have this problem. You can private chat to me. We'll just look at it together and fix it. Some of us are still struggling with installing the virtual box. Please check to be sure that your system is in order, you have the right specification and all. If you don't have that, then you just have to get a system that will enable you to that. Time is going, we can't just wait forever. So we have to move ahead. Some folks are already ahead, and I don't think they want to wait any further. So we just have to do the right thing. So please, if you need to get a system, should go ahead and get it. So last week, we ended up with module 6, which is, I think we did module 5 network protocols. So today we'll be looking at module 6. And module 6 has to do with Ethernet and the internet protocol. So I'm going to share my screen right away and then go. I want to believe you can see my screen. Hello, can we see my screen?
Yes, yes, very well.
Okay, thank you very much. So we're looking at module 6, which has to do with Ethernet and internet protocol. These two words coming hand in hand. What happened is that when you talk about the Ethernet, you're looking at an interface that provides LAN connectivity. Ethernet gives you that access for LAN connectivity. You can see your Ethernet port, like the ports you have, the RJ45 ports you have beside the system. That's what the Ethernet looks like. And the internet is the cloud we all know about, which is the worldwide network. And so here quickly, we'll just look at the objective for this course, what we expect to actually cover for the period. We need to explain how Ethernet supports network communication. And then we need to look at how IPv4 protocols support network communication, how IP addresses enable network communication, and then look at the types of IPv4 addresses that enable network communication, and how the default gateway enables network communication, and then also look at how IPv6 protocols support network communication. So all this is how all these protocols support network communication. So Ethernet, unlike wireless, Ethernet uses wired communication. Like I said, it gives you that interface for wired connectivity. It includes twisted pair, fiber optic links, and coaxial cable. If you look closely, you can see the Ethernet occupying the IEEE 802.3. Looking at that diagram on for the OSI model, you can see it to your right-hand side here. This actually tells you that Ethernet has a lot to do with your cable and then the data link layer. So it operates a data link layer and physical layer. It's a family of network technologies and defined by the 802.2 and the 802.3 standard, and actually support bandwidth from 10 Mbps to up to 100 gigabit per second. Of course, even to unlimited. Hello, please, can you just mute your mic, please? Please, can you mute your mic? Please, mute your mic, please. Okay, so like I said, it can take as much as speed up to 100 gigabits. That tells you the link, the speed link of an Ethernet. And as seen in the figure, Ethernet standard define both the layer 2 protocols and the layer 1 technologies. So here is actually an Ethernet frame field. In this field, it tells you the frame size is about 64 bytes and the maximum is 1518 byte. Which includes byte from destination of MAC address field through the frame check sequence. So we call the frame check sequence actually helps to check the arrival frame from the source. In other words, to be sure that what you get at the destination is what you get from the source. So the frame check sequence actually is there at the layer 2 to be able to help detect error and correct this error. So any frame that is less than 64 bytes is considered a collision fragment, and what we call a runt frame, and it's automatically discarded, by receiving station. So why? Because it's not in the right size. So frame with more than 1,500 bytes of data are considered jumbo or baby giant frame. So it has to be within the specified length, and that's where the FCS actually does this computation. Check what is being sent from the source and look at it from what is arriving at the destination. If there's no match, then it is completely discarded. So this is the architecture of an Ethernet frame. Recall, this is just still data, but data encapsulated at the layer 2. And then here we have the Ethernet fields and their description, which as follow. The preamble actually is the start of the frame. It's used to synchronize between the sending and the receiving device. That is at the time when you're trying to initiate this frame from the source to send across to the destination. And then the destination MAC address is identified for the intended recipient, which is the system that is going to receive this frame or this encapsulated data in layer 2. And then the source MAC address is identified at your originating NIC as your network interface card. Recall that Your NIC is where you have the source of your frame from any system or from your switch, Ethernet switch, or Ethernet from your router also has an Ethernet port. So what we're saying here is that the source MAC address is actually identified at the originating node, NIC, at the point of sending. So the type and length identify the upper layer protocol encapsulated in the Ethernet frame. And then we have the data field, and then we have the frame check sequence, like I said. It's used to detect error in the frame using the cyclic redundance check. So it uses the cyclic redundance check for the computation. And here is the MAC address format. You can see this is the MAC address for a 48-bit. Recall, this is almost this is in hexadecimal. If you look at it, it's from 0 to 15. In binary, this is the conversion rate. And then in hexadecimal, it's from 0 to F, meaning that once you get to 9, instead of you having 10, the 10 becomes an A. That's for the hexadecimal. Recall that your MAC address is the address from either your computer or from any of the Ethernet ports. And that's what it works with. It works to the 48-bit length. That's why you have it from A to F. So you could have combination of numbers like 0F, column 0A, column 2B. That's just the way the MAC address of even your computer system behaved. So here we have an IPv4. IP recall is Internet Protocol version 4, which we have two, with the IPv4 and IPv6. And let's now look at the IPv4 in terms of the network layer. The network layer is actually on layer 3, as you can see on the right-hand side. It provides services to allow end devices to exchange data across networks. IPv4 and IPv6 are the principal network layer, and that the 8 communication protocols. And then the open short part first and internet control message protocol are other network layer protocols. So they're all dependent on the network. So the open short path is one of the routing protocols we have. The ICMP is actually more internet controller message protocol. This is, for instance, when you ping, when you're trying to send an echo, or you're trying to check for connectivity between maybe like a round trip to be sure that there's some level of connection between two devices. Then you ping. So usually when you do that pinging, you're sending an echo, and that echo, that protocol that control that particular task, or do I say the activity, is referred to as the ICMP. So basic operation of network layer protocols include addressing end devices that's configured with a unique IP address. And then encapsulation. We already know what encapsulation is the transformation of data into different forms as it goes from the transport layer down to the physical layer. So at every stage, there's a change of form of data. And that unit is the PDU, which is the protocol data unit. And routing actually select the best path and direct packet towards the destination host. So when we talk about the packet, we're looking at data encapsulated at the layer 3, it's referred to as packet. And then the routing is the router is making a selection on which path to take. That's one of the attributes of the routers. They do what they call best path selection. And they do this based on routing protocols. And it could be OSPF, it could be RIP, it could be EIGRP, any of the routing protocols might actually be all the ways router makes a decision. And then the encapsulation is performed by the destination host. Recall that once encapsulation takes place, there's always a new header to the data. And that is actually what changes the behavior of data as it travels down the layer. So at the point where it is being received at the other end, it's definitely going to de-encapsulate. I mean, take off that header. And then you have your pure data. There's no system that will be receiving data and have a header on it. So all that will be removed so that the real data can be seen. So network layer, communication protocol specify the packet structure and processing used to carry the data from one host to the other. So operating without regard to the data carried in each packet allows the network layer to carry packets of multiple types of communications between the multiple hosts. As you can see to your right, that is happening at a layer 3. And if you agree with me, if you look at the diagram very well, you can see the structure. It shows you the communication between two end devices, two systems, as you can see, with two different IP addresses. This one is on .12, this is on 32.11, and this is on the 6. These are two different networks. So that means these are two different distinct network. They are like private inside of what we call private local within two different organizations altogether. And so they are also then on the OS side, meaning that it has to go down through the layer and then being received at the other end by the system. So you can see when it's leaving, for instance, if this is PCA, once it's leaving PCA, it will get to the last layer and then convert it into bits of strings of zeros and ones, and then it is received by the other system. So IP encapsulation is just what you just explained, is the change of your data from one point to the other. So the process of encapsulating data layer by layer enables the services at the different layers to develop and scale. Hello? Hello, can we hear me?
We can hear you.
Hello, sir, we
Okay.
can hear you.
You were lost to some
Okay.
point.
Oh, sorry about that. But on this same
Just
slide
like-
or the previous slide?
Only, we
The
just
same
lost
slide.
the network along the line, but we can hear you now.
Okay, lovely. Okay, so if I'm to go back, we're talking about IP encapsulation, and I said this has to do with the change of your data as it travels down the OSI layer from layer 7 down to layer 1. And recall that 7, 6, and 5 is the upper layer. And as it's going down to the middle layer, which is a transport layer, it becomes segment. And then once it gets to the network layer, it becomes packet. And then that link layer frame. And then the last layer, which is the physical layer downwards, is the physical, is in bits of. Hello. I hope you can hear me.
You are back. You were off for some
Really
time.
no, sir.
Okay, so was I off? Okay, I'm back now. But you can hear me.
Like, hello, it looked like network is not our friend today.
So
I
we
don't
can
know
hear
whether
me.
it's from me or from over there.
I can hear you now, but Doc, you were off for a while, for about a minute or two, and then you are back now.
Okay, but can you hear me now? Like you can hear
Yes.
me clearly now.
Yes, on my side,
You're
I
now
can hear
good.
you.
Okay, fine. So let's just
hear
go
you
on.
now. I can hear
Okay,
you.
thank you very much. Okay, good. So we want to look at the characteristic of an IP. IP is Internet Protocol. It was designed as a protocol with low overhead. It provides the functions that are actually necessary to deliver a packet because it operates on layer 3. And layer 3 is known for packet. And so the basic criteria of an IP is that one, it is connectionless. That means there is no connection with the destination established before sending. And two, it is best effort, meaning that IP is inherently unreliable because packet delivery is not guaranteed. So there might be some issues along the way. And so it can't guarantee you delivery of the packet. What guarantees you delivery of the packet is the transport layer, because it maintains end-to-end data integrity. So to some level, it has a protocol in place. So the media independent IP also is media independent, meaning that its operation is independent of the medium. And then, of course, remember the medium we're talking about is the channel, which is like a copper, fiber optic, or your wireless network. So it's also what connectionless. And then what we mean by connectionless is that there is no detected end-to-end connection created by IP before data is sent. It does not actually guarantees you delivery. Like I said, this is a best effort. Still, it's unreliable network layer protocol. IP protocol does not guarantee you that all the sent packets will be received. And this is for media independent. Like you can see here, IP operates independently of the media that they carry the data at lower layers of the protocol stack. So IP packet can be communicated as electronic signals over copper or whatever medium, fiber, wireless. And the OSI, remember the OSI is the open system interconnection. A data link layer is responsible for taking an IP packet and preparing it for transmission. The maximum size of the PDU that each medium can transport is referred to as the maximum transmission unit. So it is actually media, complete media independent. And then for the IPv4 packet header, recall I said the packet header is what really made it encapsulated. If you remove the header of a packet, it's the real data you have. So let's see what the IPv4 packet header is. It's one of the primary network layer communication protocols. The header is used to ensure that the packet is delivered to the next stop, which is the next layer. And an IPv4 packet consists of fields containing important information about the packet, that's about the data itself. So these fields contain binary numbers, which are examined by layer 3. So you see that the header actually contains vital information to tell what this whole packet is all about, where is it heading to, and actually helps to detect one or two things as it travels through the layers. So the IPv4 packet header, you can see the field here. It has the version, which version you're talking about. It has what we call the differentiated service, that's or what they call the diffserv. It has a header checksum. It has a time to leave, which is a TTL, which is decremental by 1 to when it is 0. It also have a protocol, and you can see here the source and the destination IP address. So this is like an architecture of a typical IPv version 4. And the entire length of this IP, recall, is 32-bit length, meaning each byte is made up of 8 bits. So let's look at IP addressing basics, because it's expected that as you're doing this course cybersecurity, you need to understand some little stuff about IP address. In summary, IPv is into 2, IP version 4 and IP version 6. And then IP version 4 actually is 32 bits length, meaning that each of the string here is of 8 bits. And by the time you multiply 8 by 4, you get 32. That's why we came up with 32 bits here. So these numbers you're seeing here, they are all numbers generated from decimal numbers within the range of class A to class E. So at the elementary level, from 0 to 1 to 7 is considered as class A, and any numbers from 1 to 8 to 191 is considered as class B, and then from 192 to 224 to 239 is class D, and then 240 to 255 you have it as class E. Sorry. So now that is the range. So meaning that any numbers within this range actually is being classified into any of these classes. So the 192 you're seeing here, 168, looking at the first octet as a determinant, you agree with me, it's a class C. So this is, and then if you convert it into binaries, then you can have all these sort of ones, zeros, and when you add and you count all these bits together, you have 32 bits. So the IPv4 address, as you can see to your right here, this is actually the IPv4 address. That means your system can actually pick it automatically if it's a DHCP, and DHCP means Dynamic Host Configuration Protocol, or statically where you assign this IP address. So it's a unique IPv4 address of the host. It has a subnet mark, which is used to identify the network and the host portion. And the subnet marks, we have it for default class A, B, and C. And if you can see from this same display here, you can see 255.255.255.0. So when you have the 3 octet, all 255s, and the last one .0 is actually class C subnet max. But when you have the first two to be 255.255.0.0, it's a class B. And once the first octet here under the subnet max is 255, and every other octet, or what they call strings, are all zeros, then automatically it's a class A subnet max. So wherever you have those 255s, recall if you convert them to binaries, you get them like this. So all 255s when converted to binary are all ones. And then when you combine that 255 ones, and in this order, so all the ones represent your network, and all the zeros here represent your host. So that is how we separate the network from the host. A default gateway IPv4 address is required to reach remote networks, and DNS server IPv4 addresses are required to transform domain names. Please, can you hear me, please? I want to be sure so that I don't keep talking. Can you hear
Yes,
me?
please, we can hear you. We can hear you.
Thank you very much.
Yes.
Okay, lovely. So you can see here the subnet marks. So when an IPv4 address is assigned to a device, a subnet mark is used to determine the network address of the device, meaning that every system that acquires an IP address must have a subnet mark. It's compulsory, because that is where it tells which portion of that network is actually for the host and which portion is for the network. So the subnet marks is consecutive sequence of ones, bits followed by a consecutive sequence of 0 bits. In some cases, you can have it all. So when you do this whole conversion in binaries, you can tell which part, which is the ones, that's your network, and then the zeros represent your host. Like you can see in this slide. Convert 190, you get it's binary 168, and when you convert 10, is what you get, and then when you convert 10 also, you get this. And like I said, because the subnet marks, the first 3 strings or octet of the subnet marks are all 255s, which are complete. The last portion, and on top of it is where you begin to vary the host. So once this octet is complete, you're working with the last octet. And here, once you add your IP address and your subnet mask, you get a network address automatically. If you really want to AND, you get the network address. So once you have an IP address and you have a subnet mask, you can easily tell what a network address is. Now, the previous length of an IPv4, like we said, is the slash, what we call slash notation. So one of the ways to make things a lot easier is, for instance, if we pick what we have here, in the previous example, 192.168.10.10. Remember, the subnet marks are all ones here, the first 3 octets. Now, if you count all the ones in the first 3 octets, it gives you 24. So the prefix length is /24, or the slide notation is /24. So we always use this slide notation to tell what the subnet mask is. So the next time you see maybe /18 or you say /16, it tells you that the first two octets are all ones and the last two octets are all zeros. So you count the number of ones, and that is where you get this slide notation, or we'll call the prefix length. So here is a very good table to give us a further breakdown of what we've been saying. If you get the default subnet mask of class A, like I said earlier, if you convert it to binaries, this is what you get here. And then it's going to be /8 because the first octet, actually, you can see here is 255, meaning that if you convert 255 to binary, you get all ones in the first octet. And of course, for what you can see here, the other octet are zeros. Okay, so same thing for, this is for B, for the class B, and you convert it to, you have this /16. So you can see all the slash numbers here. It gives you a clear view that once you convert this to binaries, count all your ones, and that forms your prefix, or what we call slide notation, as the case may be. So like I said, when you AND it, it's like when you add 1 to 1 here. In this case, you're having as 1. When you AND 0 and 1, you get 0. When you add 1 and 0, you get 0. And when you AND 0, 0, you get 0. This is more or less like what we call a logic gate. So when it's 1, 1, when the signal is 1, 1, it's 1, and 0, 1, it's 0. And this is how the numbers are being added. Like I said, when you AND your IP address with your subnet mask, it gives your network address. So you can see that in this case, when I AND this and this, I should get the network address. So there's a video for you to watch to be able to, about the network host and the broadcast address. And that will help you to talk about the network address, the broadcast address, the first usable host, and then the last usable host. And so we'll look at subnetting broadcast domain. You see, you agree with me. One thing is the network, it gives you what we call a broadcast, more broadcast. Or as a network expands and keep growing and connect me 400 users and above, or sometimes 200 users and above, you have more broadcast, because the switch, as you can, this switch you're seeing to your right-hand side, is referred to as a broadcast domain. So by design, the switch is meant to broadcast. But as the switch keeps broadcasting, based on the number of connecting devices, it gets to a point when it leads to congestion. So subnetting, of course, has come in to help reserved IPv4, but at the same time, it's also used to create further domains in a switch as a way of trying to reduce the broadcast nature of a switch. So the solution is to reduce the size of network to create smaller broadcast domains. Remember, like I said, the entire switch is a broadcast domain, meaning that how do you handle this? You can handle this by actually segmenting it and creating new domains. So when you carry out subnetting, you can actually apply that on switch so that you can give a range. If you have a 24-port switch, for instance, you can say from port 1 to port 8 can be considered as one VLAN, so that every broadcast stays within that domain. Very, very important. Okay. So subnetting broadcast devices. Network administrator can grow devices and services into subnet that may be determined by a variety of factors. So you can see here, sometimes you can actually do this by maybe department, by different units in an organization. All that can be varying factors why you might be applying the subnetting. But originally, the subnetting is actually helped to preserve the IPv4 because it helps to give you a clear view to make you understand when I mean, you don't waste IP addresses. You make sure that whatever you want to use for every domain or for every unit or department in the organization, you just go straight away and calculate it so you can preserve the IP address. So let's look at the types of IPv4 addresses. Like I said earlier, we have it in classes: class A, class B, and class C. So this is a class A from 0 to 127, and this is a class B from 1 to 8. You can see the first determinant of the first numbers here. Like I said, they're in 4 strings, or what we call 4 octets. So you can see here, C is from 192 to 223. So from 192 to 223, from your class C. There's also class D and class E. The class D is for multicast, and your class E is for experimental address block, and for research purposes, as the case may be. So IPv4 addresses and default subnet max. We've actually looked at the default subnet max for class A, B, C, and then we've also seen it from the angle of the host portion and then the network portion. It's one thing for you to actually categorize the IPv4 address, because in every connection, there's going to be a private IP address, which is actually within the intranet or within a LAN network, and that which is the public IP address, which is outside your domain, which is on the net, on the internet. So the question is that let's differentiate between a private IP and a public IP. So you can see there are blocks of addresses called private addresses, and they are used by most organizations to assign IPv4 addresses to internal hosts. So here, from 10.0.0.0 up to the point of 10.25.25.25 is referred to as a private IPv4 address. And then when you now move to class B, you see it from 172.16 until when you have it up to 172.81.255.255. So it means that the first octet or determinant remain the same. The second one in this case here is actually from 16 to 31 at max. And then you have the 0.0. And then here is 192.168.0.0 up to when you have 192.168.255.255. So this is the private. So any numbers not in this range is actually considered a public IP address. So reserved private address. In the figure, as you can see, users in network 1 or 2 are sending packets to remote destination. That's like the ISP. So the ISP routers will see that the source IPv4 address in the packet are from private. So that's what you see. So one of the ways that the private IP addresses now can be translated out of the organization and then can have access to the internet is through the protocol we call the NAT address translation. So once you carry out this configuration of NATing your private and public, automatically you are now giving your private IP addresses access to the internet. So that process is a way of trying to masquerade or try to encapsulate your private IP addresses and announce them to the internet. So let's look at the default gateway. When you hear the word default gateway, oftentimes it's like an access path in which data have to go through. So if you have a router, for instance, and this router is connected to a switch, and the switch has several systems connected to it, the interface of that router at that point becomes a gateway to those systems, because all the packets that will be sent will have to pass through the interface of that router. So let's quickly look at this. Hosting for all decision. So another rule of network layer is to direct packet between hosts. And remember, a host can send a packet to itself, which is local host, and to remote host. So you can see, for instance, from here, it can send to server outside the network. And remember, you can actually do NAT here, or you can do what we call static route. You can also apply dynamic route in some cases, and you're able to make sure the system here can talk to the server here. So whether a packet is destined for a local host or remote host is determined by the source and device. So the method of the determination varies by IP version. So for an IPv4, the source device uses its own subnet mask along with its own IPv4 address, and then the destination IPv4 address to make his own determination, its determination when he wants to send. But for an IPv6, the local router advertises the local network addresses to all the devices on the network. That's a way in which it can be sent through the IPv6. But for the IPv4, like we said, the source device uses its own subnet mask. Like I said, every IP address has a subnet mask along with its own IPv4 address and that of the destination to make a decision of forwarding packets. So I've said here that the default gateway is a network device that can route traffic to other networks. So whichever provider that interface is the gateway. So on a network, a default gateway is usually a router with these features. So you need to note this down. It has a local IP address and the same address range as the host within the local network. So it must be within that pool of addresses. So it must, the gateway to every LAN network must have its own address in that pool. It can accept data in the local network and forward data out of the local network. It routes traffic to other networks. So a default gateway is required to send traffic outside its local network. Traffic cannot be forwarded outside the local network if there is no default gateway. So there's no way that packets can leave any local network to any other network outside without a default gateway. So a host routes the default gateway, and an IPv4 host receive the IPv4 address of the default gateway either dynamically, like I said, through the DHCP, or it gets it through statically through manual means. But in IPv4, in IPv6, the router actually advertises the default gateway address, or the host can be configured manually. So having a default gateway configured creates a default route in the routing table of the PC. Remember, the PC that is connected to the router, or in this case, the switch, will always send what we call like an app, and it keeps the information of the gateway of that network. So a default route is a router or pathway your computer will take when it tries to connect to a remote network. So anytime an internet network, or what we call a LAN network, is trying to communicate with network outside with its own domain, it has to go through a default gateway. That's in summary. And so on the Windows host, that's on your system, the route print or netstart-r command can be used to display the host routing table. So both commands generate the same output. So you can actually test this on your device and see it gives you the host routing table. So you can see the gateway and all that. So you can see from here, entering the netstart-r, like you can see, command display 3 sections related to the current TCP IP network connections, which is your interface list, your IPv4 route table, then the IPv6 route table. And in this case, you can see from the third column here, you can see it giving you an access to the gateway. You can see the gateway being displayed. So we're going to look briefly on the IPv6. We've talked much on IPv4. IPv6 is 128-bit length. In other words, it's longer than the IPv4. IPv6 works with hexadecimal, and IPv6 have 16 bits in each string, unlike IPv4 where you have 8 bits. And so when you multiply 16 by 8 of these strings, you get 128-bit length. So the IPv6 is designed to be the successor of IPv4. Different continents are beginning to use IPv6 as we speak. So before now, it has been IPv4. So mobile providers have been leading the way with the transition to IPv6. So most top ISP content providers such as YouTube, Facebook, Netflix have also made the transition to IPv6. Many companies like Microsoft, Facebook, and LinkedIn are actually transitioning to IPv6 only internally. So this is a very high improvement in terms of the acceptability of IPv6. And one of the things that actually draw the attention of this high usage of IPv6 is the Internet of Things. So as you have more and more devices connected to the internet, you realize that there's a need for IP addresses to cater for all these new devices. And that is why when IPv6 sprang up, it became obvious that there's a need to with the IoT, with the advent of the IoT, required that you need IPv6 because about 3.6 on the ceiling, so that you can be able to cater for more devices. So you can see here from the picture to your right, it gives you a clear view of how IPv6 is being breakdown. IPv6 addresses are 1 to 8 bit line, like I said. Every 4 bits is represented by a single hexadecimal for a total of 32 hexadecimal values. So each of these values is 16 bits. And for each of them here, you can have 32. And then if you multiply it across by 8, you have 128 bits. So it's actually written from 0 to 0000 to FFF, which is the last. That's from your 0 to 15. And like I said, each of these bits is actually in 16 bits. So you can see here, the fourth, we call it hextent. The fourth hextent of an IPv6 is actually also referred to as a nipple, and is where you have the broadcast. So meaning that if you want to generate different subnets in IPv6, all you just need to do is begin to bury the fourth hextent. So this is more or less like a preferred format of an IPv6. So you can agree with me that you have it in hex, with the column, and then you have it 8 strings like this, or called 8 hextents. And the preferred format, so the preferred format for writing an IPv6 address is putting it in column, where the S is consisting of 4 hexadecimal values. And as we can see the example here below. But we also have methods in which we use to work on IPv6. Looking at it, that is quite long. It's always very important to have a way of shortening this. So one of the ways is there's several rules, like the rule of omitting any leading zeros. So more or less like what we call the rule of, another way of looking at it is the rule of suppression and compression. So if I take the leading zeros, I'm saying that any of the hextents that start with a 0, you take off the 0. The computer definitely will understand that there's a 0 there. All this is a way of trying to compress this string so that it becomes smaller and easier to manage. So you can imagine writing an exam. You're meant to configure a particular interface, and you have to type all this just to configure an interface. You can see how long that is. So this is a way of trying to compress it. So by the leading 0 is to remove the first 0 from it. Like you can see here, if you have 01AB, becomes 1AB, and if you have 09F0, becomes 9F0. So in this case, where you have 00AB, all you need to do is remove the 2 zeros, and you have this AB. Like I said, the system still understands that it's a 00A. Of course, it has to be 4 hexadecimal. So this is the rule 2. The rule 2 is to replace the double column where you have consistent 0 bit. Anywhere you have, for instance, if you look at this example here, I have 000. Then after the next column, you have another 000. You can see all that. So the rule says that whenever you have this set of strings coming together side by side and they're all zeros. Take them off and replace them with double zeros. And one thing, that's where the compression comes in. It's being compressed into that small form. So you can see finally, you have it as 200 DB8, 0, and then 111, and then you can see all column, and then 200. That tells you that at the third extent, so the first extent is taken, second extent is taken by removing the leading zeros, which is DB8, and the third extent, you now have, when you remove the leading zeros, you have 10. Then when you go to the fourth extent, recall they are all 1, so you leave it there. Then the fifth extent, sixth extent, and seventh extent are all zeros put together. So all you just need to do is replace the double column. And this double column, you only do it once, please. So you don't say, oh, because I have 000 here, strings of 00 in 2 different extents, I can make a double column. And maybe at the beginning you have same. No, you don't have 2 double columns in one IPv6 address space. You only have to make it 1 double column in a situation whereby you have consistent zeros, at a very close range, just next to each other in this format. So this is the IPv6 address, is 128-bit length, meaning that the first 164-bit is referred to as the what we call the prefix, and then what we call the network ID, and then the last 64-bit is referred to as the interface ID. It's good you play this video so that you can actually cover the difference between layer 2 and layer 3. And then you also look at the characteristics of the layer of IPv6 addressing. And then looking at, so this video will go a long way to give us a further breakdown. So the Ethernet and IP protocol is what we've been saying all the while. So in summary is the Ethernet, please can you mute your mic if you're not asking a question? So the Ethernet, like we said from the beginning, is the 802.2 and the 802.3, which takes care of both your layer 2 and layer 3. So it provides that interface for LAN connectivity. And then the IP protocol, we've taken our time to look at IPv4, saying it's best effort delivery, it's media independent, it's connectionless and all that. We actually looked at those characteristics for the IP, and then we went further to say it as IPv4, IPv6, and then look at the differences between the two, and then look at the structure of a typical IPv4 header, and just like we look at that IPv6 and all that. And all this is just to give us an idea that as an IPv4, you have a private IP IPv4, so that when you're carrying out an investigation of an attack, you can tell if the attack is within the organization or outside the organization. So the IP address will tell you to let you know if this is a private IP or it's a public IP. So we need to know all this at this level. The reason why we're doing this is because IP address has come into play, and the hacker would definitely have to use a system somewhere to get to hack into your system, your own network. So he must have an IP address in the system. He must be connected to any network that gives him access to your own network. So we need to understand the difference between the IPv4 and IPv6. So I'll pause at this junction and give us room to ask questions if there are questions. And there are no questions, then I can move ahead. So do we have questions? I think that will help me to explain better. Do you have questions? Hello, are we there? Can you hear me?
Yes, Doctor, we can hear you.
Oh, lovely. So are there questions?
No, thank you so much.
It's okay.
Okay, so if there are no questions, then we'll just go ahead and then can move on with the next. So like I said, in summary, it's just for you to know that at the end of the day, you'll be carrying out some kind of investigation to tell if a network is actually private public. So please mute your mic if you're not saying anything. Okay, so we'll look at module 7 quickly, which has to do with connectivity verification. It's one thing to be sure that you're connected. A number of folks try to get in touch with me and say, oh, I'm not getting these results. And sometimes if you check, you need to be sure that your system can actually connect to the internet. Remember, in the first class, we tried to check the CyberOps and see if the CyberOps can connect. And that's one of the first investigations you carry out, so that you'll be sure that that CyberOps you're using to carry out your analysis is connected to the internet. Because most of the activities you'll be carrying out here as a cyber security analyst is on the web. And that's why it's cyber, because it must be on the web. Okay? And so the connectivity verification, how do we verify connectivity? Let's quickly look at the objective of this module. It tells us quickly that we need to explain how ICMP is used to test network connectivity. I did mention about ICMP, and I said you use it as a tool for testing connectivity. Most of us here who probably have taught CCNA1 or TCN2 before, or even though you're new, one of the fast troubleshooting and tools you use oftentimes to test for connectivity is the ICMP. So we're going to look at how to explain that, and then look at Windows tools like ping and traceroute to verify network connectivity. And the good thing is that there's a lab here too that you can begin to do. So we said ICMP is the Internet Control Message protocol. The TCP/IP, which is the Transmission Control Protocol, Internet Protocol, should actually provide messages to be sent in the event of certain errors. So these messages are sent using the service of ICMP. And that's what it uses. And then the purpose of these messages is to actually check for a feedback. It's one thing to actually check if you're connected. Like when I say, hello, are we there? Can you hear me? It's a way of checking to see if there's a feedback, and means I'm connected. But let's assume you guys are not there and I'm online and I'm trying to check to see if I'm connected. I could just ping maybe Google and see maybe I ping 8.8.8, and if it's replying, I say, okay, fine, I'm connected. I mean, there's always that test. So the purpose of these messages is to provide feedback. So it's to check if there's connectivity. And we have the ICMP for version 4, which is for IPv4. And we have it for version 6, which is the ICMP version 6, so it's for IPv6. So you can have it so you can see that you're doing it for version 4 or version 6. So an ICMP echo message can be used to determine if your host is operational or the host is not available. So you can see in that echo request. So the echo is the ping. You're trying to check the real physics. Those of you who did physics, you agree with me that when you send an echo, you get to hear yourself back. That's a feedback. So when you ping, you need to get a response. In this case, it's either it's replying or it is not, the case may be. So when we do the practicals, we'll be able to see that you have your CyberOps and then you're asked to ping certain gateway or ping certain IP address, and then you get a reply. So once you do that and you get a reply, perfect. That means you've actually done justice to this particular module. So this module is just a way of saying, can you ping? And the good thing about the CyberOps class like this is that after going through this theory, you go back to the labs, you try to walk through the labs, and it gives you an insight of why you are actually studying ICMP. So for every part of the theory, there's a practical side that gives you an insight of what is expected. So this is all about testing for connectivity, and be sure that you have a response. And like we said here, it could be on IPv4, on IPv6. So maybe it's 4, you see ICMP version 4, and if it's on 6, it's ICMP version 6. So the message will include a code that indicates why the packet could not be delivered. So it gives you reason each time you send this through a host gateway. So when you send this IP, sometimes most of you check, you see to tell you destination unreachable. Sometimes it will ping, sometimes it will tell you timeout and also. So when the 0 is the network is unreachable, when it's 1, the host is unreachable, when it's 2, the protocol is unreachable, and when it's 3, the port is unreachable. So ISMB version 6 has slightly different codes for destination unreachable messages, unlike the IPv4. So the time exceed is more or less like a time to leave. So sometimes it's used by router to indicate that the packet cannot be forwarded because the time to leave field was decremented to 0. So like I said, it's decremental by 1. And so once that time is exceeded, it goes to 0, and then you start seeing timing. So if your router receives a packet and decrements the TTL feed in the IPv4 packets to 0, it discards the packet. That means it's not longer needed. And that is why some of the loop avoidance or loop issues is that with the decremental value of an IP address, sorry, an IP, when a packet is actually traveling around the network, it's as good as the decremental by 1 until it gets to 0. You know. So same thing for the IPv6. So ISMB version 6, and then look at the IP, and then the array, which is a router advertisement. So we have a router solicitation, and the ISMB has a new features. That's for the version 6. And then it improved functionality not found in the IP version 4. So the ISMB version 6 messages are encapsulated in IP version 6. Recall that your configuration can be in IPv4 or in IPv6. So we're saying in this case that when it is in IP version 6, this is the outcome. So it has 4 new protocols as part of the neighbor discovery protocol. And then message between an IPv4, IPv6 router and IPv6 device. So router solicitation message, the router advertisement message, this is between the IPv6. So the neighbor solicitation message and the neighbor advertisement message. So let's see how we put that together. Okay. So the router advertisement message are sent by routers to provide addressing information to host using the stateless address auto configuration. Now, when a router will send an array message periodically or in response to an RS message, a host using the Slack will set its default gateway to the link local address of the router that send the array, which is a router advertisement. So this is actually a message between your IPv6 router and your IPv6 device, meaning that your router that is configured with an IPv6, and then your device is configured by an IPv6. So when a host or a device in this case is configured to obtain its addressing information automatically using the Slack, the host will send an RS message, a solicited message to the router requesting for a router advertisement message. So as you can see from the diagram, you can see the exchange between the router and the system. Now, this is happening in the case of in the case of ICMP version 6. Each time you send an echo from the system, these two protocols must be exchanged in order for it to be able to probably acquire an IP address, in this case, before sending the data. This must be established. So it's a protocol that must take place between a PC configured for IP version 6 and IP version 6, especially when you're sending an echo to text for connectivity between the two systems. So there's also a lab to this effect, which you need to do. But in the case of duplicate address detection, so when a device is assigned a global unicast or link local unicast address, because for IPv6, we have the global unicast, we have the link local unicast. This actually is another way of trying to look at IPv6 from the perspective of private and public address. So the duplicate address detection is performed on the address to ensure that it's actually unique. So to check the uniqueness of an address, the device will send what we call the non-solicited message with its own IPv6 address. So if another device on the network has this address, what happened? It will respond with an NA message, which will notify the sending device that the address is already in use in the case of a duplicate. And if a corresponding NA message is not returned within a certain period of time, then the unicast address is unique and then acceptable for use. So it has to check to see if there is no duplicate. That means there's no existing system on the network that have the same IP address. But all this has to more or less like an exchange in the case of a wireless network where you have a probe and the beacon. So this exchange must take place between the router and the systems to be able to tell if you already have a system within a network that have that IP address. So let's look at the ping and trace utility. One of the ways you can do this, one, you can play this video to actually watch this. But then the connectivity that ping is an IPv4 and IPv6 testing utility. So you should know that it's used for testing. So in summary, what we're saying here is that your ability for testing for connectivity will be needed in the case of carrying out your investigation into any crime or into any attack, as the case may be, most likely when you're suspecting this attack coming from any of the devices. So to test connectivity to another host on the network, you must send what we call an echo through the ping to the host address. So using the ping command. I want to believe everybody here can ping, but if you can't, like I said, there's a lab section that you have to try your hands on it. So it responds with an echo reply to tell you whether it is replying well or it is not. And each echo is as each echo is received, ping provides feedback on the time between when the request was sent and when the reply was. Sometimes it could be quite large. So you could be replying at only 1 millisecond, and sometimes you see, so that tells you the time it takes for you to get the response. So ping has a time value for reply, has a time out value for the reply. So in case sometimes it goes out of the time range, to start a timeout. If a reply is not received within the timeout, ping provides a message indicating that a response actually was not received. So you can after all the requests are sent, the ping utility provide a summary that includes the success rate and the average round trip. So you can see it most times when you do this ping maybe from a router, it gives you the rate, sometimes 25%, maybe 50%, as all the case will be. So type of connectivity tests performed with ping include the following. When you ping a local, look back, when you ping the default gateway, and when you ping the remote host. Sometimes you ping your system. You do a test, a look back test on your system by pinging 127.0.1, just to be sure that your system can ping. In some cases, you ping the gateway and say, am I sure I can be able to check my gateway? You ping your gateway and you're fine. You say, okay, my gateway is fine. And the next thing you want to ping any of the system outside your network to test for connectivity. So for the ping loopback, like I said, you can ping within the system. You can ping for, in the case of IPv6, is double column 1, as you can see there. And ping the default gateway. You can always ping the default gateway, which is the interface IP address of the router directly connected to a set of systems through a switch. Can be referred to as the default gateway. Then you can see that from this diagram on the right, you can see his IP address given. So the IP address at the top here You can see the gateway IP address right at the B. To be sure, that's the IP address of the interface of this router. So the interface of this router IP address become the IP address you're going to assign to your system. That's in the case when you're doing it manually. But if you're doing it automatically through DHCP, your system will naturally get that gateway IP address. I remember long ago when before we got into DHCP, most of the systems were actually running on static IP, before everything became dynamically assigned. So you can also ping the remote host, that's a host outside your network, and then see if it is responding. Then you can do another thing is what we call the test the path, which is traceroute. So this is used to test connectivity between two hosts, but does not provide information about the details of devices within the host. So your traceroute is actually a utility that generates a list of hops. When we say hops, we're looking at the number of routers away. So you can actually trace and say, oh, and then our tools also that can help you. It's a ping plotter. Ping plotter is also good. It's a software tool that you can install on your system and gives you the number of hops away. That also can be seen from the perspective of the traceroute. A traceroute is actually a command in this case where you can actually check to see the number of hops away. And there's a practical, the good thing about this, a practical to this. So that's why I'm advising everybody. As we do this, you go pick up your labs, take your server workstations, check it out and say, okay, how do I perform a ping? How do I perform the traceroute? And then you're good to go. And so the traceroute, like I said, round trip time, this is the RTT. So the traceroute provides a round trip time for each hop along the path and indicates if a hop fails to respond or not. So traceroute is all about the number of routers away that you're connected to. And then it gives you a kind of a clear cut of, before you get to your destination, you're 10 hops away, or you're 5 routers away, 6 routers away. So the IPv4 TTL and IPv6 hop limit, the traceroute uses the function of the TTL field in IPv4 and the hop limit field in IPv6. And there are 3 headers along with the SMP time exceeded message. So the first sequence of messages sent from traceroute have a TTL field, val of 1, which causes the TTL time out the IP version 4 packet. So you can see here that all it does is to give you the number of hops. So like you can see in the second case here, where they progressively increment the TTL field from 2 to 3 to 4 as it goes. So it begins to count the number of hops away. So, and that's what your traceroute do for you. So let's look at the typical architecture of an ICMP. In this case, ICMP acts as a data play load with an IP packet. So it has actually a special header data field. So you can see the data field of the ICMP. So it uses messages code to differentiate between different types of ICMP messages. So these are some common messages codes. For instance, your 0 is your echo reply to a ping, and then your 3 is destination reachable. Your 5 is redirect. That's use another route to this destination. And in the case where it uses 8 is echo request for ping, and then 11 is time exceeded. The time is exceeded as the time to leave becomes 0. And at this point, it is discarded from the network. So there's a packet tracer here. Verify IPv4, IPv6 addressing in this packet tracer. You do the following: verify IPv4, IPv6 address, configuration, test connectivity with ping and traceroute. So it's expected that we should do this. Check this out. And if you're having any challenge, please feel free. In the next class, I'll pick up this lab if it's possible, so that we'll just do this command. Like I said, the ping is just to ping the IP addresses at the 2 different links between 2 end devices, and just to be sure there's connectivity, and for the trace route is to be able to check how many hubs or how many routers away. So connectivity verification, so we'll actually look at this. So like I said, in summary, is that you are just trying to test to be sure at every point in time that you're connected and you're sending an echo. And when you send an echo, you expect to get a feedback. So the feedback can either be positive or it can be what negative. Hello.
Hello, your audio went off.
Hello?
Also, okay, but now you can hear me.
Yes, please.
Okay, so if you can hear me, what I'm trying to say in summary is that all about what you're doing in this model is just to test for connectivity. So your ability to be able to test for connectivity shows that you've actually used the ISIM effectively. Any question? Any question? I want to ask again. How many of us actually new to, maybe if you have not done CCNA1, can you just raise your hand? Before you've not done anything on networking, can you raise your hand? Okay, I can see Peter, I can see Jonathan. Okay, these are two folks. So what it means is that I will put you guys on CCNA1 to also help you a lot to be able to just go through the material to help you establish some of these configurations we're talking about. Like the IP address we're talking about, you can actually configure all that at the CCNA1 level. You can check for connectivity, you can play around IPv6 and all that. So very, very important. I also have, I've said this before, but I think I'll provide that for the two of you. I have recording for CCNA1, CCNA2, and all most of those course material, so that you can just play them between now and the next class, and so that you can bring yourself into a good standing with what we're doing. However, the summary of all this here is just to check, to do some verification. So as an analyst, you're just doing some analysis to be sure that you carry out an investigation, and then the investigation, you're getting the feedback, and this feedback, you're analyzing the feedback to actually do a proper reporting. I can see a hand being raised. Hello. Okay.
Hello.
So I'm going to stop at this point. There's a question. May I ask me a question? Please, you can go ahead, Adil, if you have a question. Hello.
No question. Everything is clear.
Do you hearing my voice? Doctor, do
Please
you
go
hearing
ahead.
my voice?
Yeah, very well. Please go ahead, please.
Okay, thank you very much. In our labs, there are some of them. We have to analyze something. I don't know how can I do, so I don't send them to you. And in chat box, I asked you about the class D and E in IP addresses. I don't know what they are and what the usage of them.
Okay. For the IP address that you don't know, I could just, like I said, I will, let me do that right away. I will start doing that now. I have series of recordings for the CCNA1, which really talks about the IP address. So it will be best you play this video of that CCNA1 to help us.
I don't have, excuse me, I don't have a problem with IP addresses. Just the D and E, the last two classes, I don't know what about them exactly, just them.
Okay, you're fine
the
with
usage
the
of
IP
them.
address.
How can? Excuse me.
Yeah, if I get it clearly, you don't have issue with IP addressing. Am I correct?
Yes, just with the usage of the two classes D and E.
Okay. You the usage of class D and E. Is that what you're saying?
Okay.
Okay. The class D is actually for multicast. And for
Yes, yes.
multicasting, it's when you're actually sending it to a group of targeted systems. For instance, when you're listening to radio on the internet, it's actually a kind of reserved for such kind of protocols of sending information to group of system. So when you send to when there are transmission of signal to group of targeted systems is multicast. So those IP addresses are reserved for applications or sensitive. Please, can you mute your mic if you're not talking, please? Can you just mute your mic, please? So those set of systems or set of protocols or applications use that range of IP addresses, meaning that you're not expected to use them as a network administrator to configure on your network for any reason, because they're already preserved for that purpose. And then for the class E, which is from 240 to 255, as the case may be, is actually reserved again for, in this case, for research purposes, and some other uses. So it's not for you as an administrator to make use of such IP addresses. And it's also in the material, so you can just see ID for multicast and then E reserved for research. I don't know if that's okay. And then do we have anybody who I could make it open, very interactive, so that you can hear from others?
Hello, doctor.
Yeah,
Okay,
I'm with you.
and the labs with me?
Technically,
Yeah, go ahead.
Yeah, the group D
Who will
address,
talk?
that's the multicast addresses are used by routing protocols.
Yeah, that's okay, so correct. You also use it for routing protocols, exactly. And in the OSPF also does that in some cases. So like we said, it's reserved. It's reserved for some special. Are you okay with that contribution?
So, Doctor.
Yeah, go ahead, please.
So during, I think at the start of the modular 1, when you look at the slides, there was a packet tracer course. I think it's about 2 hours to be taken for those of us who don't have much knowledge in networking. I don't know if you can suggest to those who don't have network a background in networking to also take up that one.
Yeah, and that's for the lab, right?
Yes, it's a packet tracer. I think it's just 2 hours. So that one you can be able to have a, let's say, real-time hands-on practical configuration of the networks.
Yeah, I think that would be useful. Maybe Jonathan and Peter, if you can hear me clearly, you can explore that. You can also explore that to see how you can play around with it. It's also
so
there.
This Peter talking, and I'm currently like enrolling on it.
Oh, lovely. So, but how are you finding it?
I think it's helping, at least with the diagrams that you are using to explain. Over there is the same thing that we used that I'm learning. So I think I'm becoming conversant a little bit.
Yeah, it would be nice if we can all have our packet tracer installed.
So I also have that one installed on my PC.
Oh, lovely. So Peter, you can also do the same. And the video I have for the CCNA one, like I said, for those of you who are new to this course, I could make it available for you. And then you will just play it. And then enrolling into, that means you're going to multitask yourself, which is, there's nothing wrong with that. I can enroll in CCNA one, which is like a free piece. In this case, I'm trying to help you. And then you also watch the video at the same time. So it gives you a step-by-step guide on how you start connecting devices, configuring IP address. In fact, I even taught how IP addresses, class A, class B, and all. So you can just take your time and listen to the video. It will be helpful.
Thank you very much.
we'll explore all that, why we're doing this. It's combining this learning curve be very, very good for beginners, especially for those who don't have CCNU knowledge. But finally, when we get towards the end of this course, you realize that you just need a bit of this knowledge. I mean, understanding these protocols, how to, send packet from one system to the other. Once you can be good with the fundamentals, nobody's asking you to do so many configurations. Most of the things you're doing is you're carrying out analysis, we're carrying out some tests, and then you're reporting, just reporting what you find out. But it's good. You also have a deep understanding of what to follow. So enrollment into this, please, on the group chat, those of you who are really interested, just send in your name again on the group chat, your email address, so that I can quickly do that. I promised that before, but this time around I can see it's becoming highly needed to help others. So kindly just send in your name, email address again. I will do that enrollment immediately. So meaning that you'll be doing that while you're also part of this class to help you a lot. And like he suggested, you can also play the video for the packet tracing. Any other question? Hello? Hello? Have I lost us?
Yes, we are here.
No, we
I
can
lost
hear
you?
We can hear
Okay.
you, sir. We can hear you.
We can hear you, sir.
Yeah. Okay, so if there are no questions, then like I said, I would advise that we take the assessment seriously, and then we report it when necessary in case we have any issue. So catch you guys tomorrow.
Sir.
So I'm going to send the
Hello, sir.
The material so far for what we have covered. Yeah, go ahead, please.
Yes, sir. Like the last class, you said I should private chat you, but I did that in class, sir.
Okay, on.
About
you prioritized me on. Is it?
My down, yes. Concerning
Your
the downloads, sir. Concerning the downloads.
The download.
The resource, the resource download. Yes, I actually private chat you.
Yeah, I have shared the link for downloading the virtual box. I said, are you the one having issue with opening your CyberOps?
Not the CyberOps, sir, the virtual box. So, but I discovered it's a requirement. So the hardware requirement. So I'm working on that, sir. So I just said I should inform you that I've not been able yet to download, and so I could not do the labs yet.
Can we just have like if you could have a section? I don't know your time. Which country are you chatting from?
Yes, I'm in Nigeria, sir.
Okay, fine. So we share the same time zone. So is it possible, like maybe 8 a.m. tomorrow, you come online and you share your screen with me, and let me see what you're doing?
I will try. Actually, sir, what I've discovered is my hardware requirement.
Okay, so you didn't meet the requirement.
Yes. So I said I should just put you in the know. So I'm trying to make sure I meet up the requirements.
Okay.
So once
that's
met,
noted.
I'll now let you know. Yes, sir.
Okay, fine. You said the name is. Let me just note it down.
Olakpade, sir.
Okay.
Olakpade
Okay, okay. So, Mr. Lord, there's no cost for. You can just go ahead, get the right specification, and then.
Thank you so very much, Doc.
Okay, thank you. Okay, so see you guys tomorrow. I'll send the recording immediately now, and then the PowerPoint. Yeah.
So, doctor.
Yeah.
So till now, I'm still having issue with the security owner. The one I'm downloading with the link provided, it seems I don't know whether it's a corrupt file.
Oh, really?
So I'm not. Yeah. So I'm not able to install it in the virtual machine. So that is my problem now.
Where did you download it from? Is it the one that was shared on the platform?
Yes, please. Yes, please.
Okay, let me drop you another link on the list. But kindly remove what you have there. I don't know if that should be clear. Just remove what you have. I'll send another link again.
Okay. Thank you very much.
But when you're doing that, restart your system. So
Okay. Thank you very much.
You're welcome. Thank you all, and see you guys tomorrow.
Thank you, Doc. Bye, sir.
Yeah. Good night.